You know, we've all been there. You're standing at a street corner, you're tapping that crosswalk button over and over, and you're wondering, does this thing actually do anything? Well, it's one of those little everyday mysteries. And today, we're going to solve it for good using the power of statistics.
Right? That's the big question. It crosses everybody's mind. You push it, you might hear a click, maybe a little light comes on, but are you actually making that light change faster, or are you just, participating in a little bit of street-side theater?
So, let's treat this like a real investigation. We're going to forget about gut feelings and suspicions. We're turning this very common question into a case we can actually solve by gathering some evidence and letting the data tell us the truth.
I mean, this experience is totally universal. That feeling of waiting and wondering if what you just did made any difference at all. Well, today, that uncertainty is over, because we're going to arm you with a method to find out for sure. Okay, so how do we crack this case? Well, first we have to stop thinking like an impatient pedestrian and start thinking like a statistician. And that just means we need to frame the problem with some clear, testable logic. The whole mystery really just boils down to two simple possibilities. See, if the button is a total fake, then you're just showing up at a random point in a fixed cycle. That means, on average, your wait should be about half the total time of that light cycle. But if the button works, it's actually calling the light for you. It's interrupting the cycle. So your average wait should be way, way shorter.
Now, to really measure the difference between those two scenarios and figure out which one is true, we need a special tool. And for this investigation, our tool of choice is a cool statistical method called the one-sample t-test.
Now, don't let the name scare you. Seriously. Just think of the t-test as our detective's magnifying glass. It takes the average wait time we actually go out and measure, and it compares it to the average wait time we'd expect if the button was a fake. It tells us if the difference we see is real, or if it could have just been random luck.
So, in statistics, we make it official by setting up what we call hypotheses. The null hypothesis is basically the default assumption that the button is a dud, it does nothing. Our mission, then, is to see if we can find enough evidence to reject that idea and instead accept the alternative hypothesis, which is our hunch, that the button actually works.
All right, enough with the theory. Let's put our detective tool to work and actually crack this case with a real example. We're going to walk through all the numbers step by step.
So first things first, we need to know the full cycle time of the light we're investigating. Let's say we've timed it, and we found that it takes exactly 60 seconds to go from one walk sign all the way back around to the next one.
Okay, so if that button does nothing, that's our null hypothesis, remember? Then our expected average wait time will be half of that 60-second cycle, so 30 seconds. This number, 30 seconds, is our benchmark. It's the value we're testing against. Now for the fun part, the evidence. Let's imagine you go to that corner 5 different times. You press the button the second you get there, and you time how long you have to wait. These right here are your raw data points, your observations from the field.
So, the first thing we do with our data is find the average. Pretty simple. We just add up our 5 wait times and divide by 5. And in this case, that gives us an average wait of just 17 seconds. This is the heart of our evidence.
Let's put that into perspective. Our measured average is only 17 seconds, compared to the 30 seconds we'd expect if the button was broken. I mean, that difference looks huge, right? But in statistics, looks huge isn't quite good enough. We have to prove it.
This is the crucial question. Could we have gotten an average of 17 seconds just by pure dumb luck, even if the button was fake? Or is this difference so big that it has to be real? Answering that question is exactly what the t-test was designed for.
So the t-test crunches all our numbers, our average wait, the expected wait, how much our times varied, how many times we measured, and it boils all that information down into one single score. In this case, our t-statistic is negative 4.08, and that negative sign, it just means our average was less than what we expected, which is a very good sign. Okay, we have our evidence, we have our t-statistic. It is time for the final step, to interpret these results and deliver the official statistical verdict on our crosswalk button.
That t-statistic leads us to the most important number in this whole investigation, the p-value. Now put simply, the p-value is the probability that we were fooled. It's the chance of getting wait times this short just by random luck, assuming the button is a placebo. So a tiny p-value means it's really, really unlikely we were just fooled by chance.
Now scientists and statisticians, they have a rule of thumb. If that p-value is less than 0.05, That's a 5% chance of being fooled by randomness. We get to declare the result statistically significant. It means we have strong enough evidence to throw out that null hypothesis and say, yeah, our button probably works.
So for our example, a t-statistic of -4.08 gives us a p-value of less than 0.01. Whoa! That means there's less than a 1% chance we were just fooled by random luck. Since that is way below our 0.05 cutoff, we can confidently deliver the verdict, case closed. The evidence is strong. This button actually works.
You know, to put it another way, the odds of you just randomly showing up 5 times at a 60-second light and getting an average wait of 17 seconds are incredibly, incredibly low. The much more likely explanation here is that the button is doing exactly what it's supposed to do, making that light change faster for you. So we solved our little example case. But the best part about this whole method is that you don't have to take my word for any of this. You can now be the detective for any crosswalk button in your own neighborhood.
And if you do decide to run your own investigation, here are a few pro tips. First, more data is always better. Try to get at least 20 measurements. Also, try to collect them at different times of day so you're not just measuring weird rush hour patterns. Be consistent, and hey, if the light is already green for you when you get there, that's a valid data point. Your wait time was 0.
You know, this simple statistical tool, it doesn't just work on crosswalks. It's really a way of thinking. It's a tool for turning your curiosity into actual answers. So the question I'll leave you with is this: what other everyday mysteries are out there just waiting for a little bit of data to solve them?